Okay, so welcome back, everybody. Okay, we're going to go ahead and kick it off. We're going to go ahead and start tonight on Module 7, Page 3, folks. Okay. I'm sorry. Excuse me. I'm sorry. Module 7, folks, Page 9. I apologize about that. I actually had the wrong page number in there. Okay. Um, Field safety book. So we left off last week just to kind of let everybody know what we picked up on last week and kept on going. We went ahead and finished Module 6 last week, aerial lifts. We finished that and scissor lifts. We also finished all of construction heavy equipment as well, Module 6, and then, end of Module 5, then Module 6, and then also Module 7 as well. So we just started Module 7. They're also uploaded, folks, just so you know, they're also uploaded to YouTube now. So if anybody wants to catch those modules, you'll notice that now, rather than naming everything by date, we're naming it by book and by module and page number, okay? That way it's easier for everybody to keep track of what they have going on. And so we'll go ahead and cover that, okay? All right, folks, so let's go ahead and kick off. Like I said, we got through page 7. Okay, we wrapped up on communication. And then if you look at page 8, we had left off last week on the operator's daily checklist. And there's just an example, right, of an operator's daily checklist. And you'll go ahead and notice that this is for a crane checklist, right, or heavy equipment. And you'll notice that we're talking. It shows all the guards, the devices. Okay, looking for any type of leaks, looking for condition of tires or tracks. So there's a checklist for everybody. Okay, just in case you want to check it out. Let's talk about maintenance a little bit. Obviously, heavy equipment, we know that it can be prone to breakdown just like any other equipment, right? So we'll be doing proper maintenance on it, make sure that we're doing routine and proper maintenance on it. We also know that those malfunctions, what can they do? They can basically, we know that ultimately what they can do is go ahead and cause a failure in the equipment, right? So there's always a significant risk there. So we want to make sure that we keep up on that scheduled quarterly maintenance, monthly maintenance, and then annual as well, inspections, okay? So manufacturers, basically, they're going to supply that detailed operating and maintenance manuals for us. That's why how often do we talk about, do we have the manual, right? Do we have the manual for a piece of heavy equipment? Do we have a manual for a crane? And the biggest and the most important thing is that it provides our inspection process. But the same goes for a scaffold, right? The same goes for our fall protection as well. The manufacturer ultimately is going to be the one that determines what our scheduled maintenance and our repair maintenance is going to look like. Okay. So while performing maintenance on equipment, these are the certain things we want to keep in mind, right? We want to make sure that we disconnect the power and then lock out and tag out any machines before we perform any maintenance. So before any type of employee gets their hands or any body parts into that piece of equipment, we want to make sure that we're locking out and tagging out. At a minimum, taking that key, grabbing custody, and tagging it out, and making sure that there's no other key in circulation. Okay, folks. In addition, we may have to block hydraulic arms or lifts if they're in a position where they may possibly harm an employee. We also want to use properly fitted wrenches on nuts and bolts. We talked about that last week, right? Rather than using items like channel locks or vice grips, we want to use fitted wrenches, okay, or fitted sockets. And for the reason being is that we want to go ahead and minimize the risk of any type of slippage where it may possibly hurt an employee. But also, in addition to that, we want to be able to tighten down and torque down as necessary as well. And then also, in addition to that, we want to dispose of incombustible materials properly. Like we talked about last week, if we have any type of oily rags or any type of oily materials, we want to go ahead and make sure that we clean up, pick up, and also put any oily rags or materials into some kind of container with a self-closing lid. That way it doesn't have the breathable air and the oxygen that it would need in order to possibly spontaneously combust, okay? Also, we want to store, that's what we're talking about, storing oily rags in self-closing containers, and then ultimately never using compressed air to clean ourselves. Never using compressed air to clean ourselves, or ever using compressed oxygen to clean ourselves or anything, okay? Anybody out there tonight that's on the line, do y'all do any type of, do your employees do any type of compressed air cleaning? Like do they use any type of compressed air to do blow down on equipment or tools or anything else? Okay, good. Okay. Okay, a couple of you do, a couple of you don't. Just keep in mind this, right, is that we want to make sure that it's regulated down. And I'm going to show you the standard. As a matter of fact, let me go ahead and pull the standard up on that right now, okay? So anytime we're using compressed air, folks, that's what I'm doing right now, just so you know, is I'm pulling up. I know it's 30 PSI is what the standard says, actually letter of interpretation and the standard. And here you go, is anytime compressed air, it shall, you see here that it should not be used for the purpose of cleaning, right, except unless we reduce it down to under 30 PSI, okay? So actually, it's going to wind up being an air pressure reduction tool. So let me show you an air blowdown tool, and I'll show you what I'm talking about as well. This is what I'm talking about, folks. You may see some blowdown tools like these. You have different types, okay? Anybody familiar with what I'm talking about now? Have you seen those out in the workplace? The biggest thing that we okay, great. Okay, the biggest thing that we want to do with it is that, let me see if I can pull up the Husky really quickly. Let's see. Biggest thing that we want to make sure on it is that when we do the blowdown tool, we want to make sure that it's regulated down to 30 PSI or less. So the easiest way to do that is just making sure it's stamped. Okay, just making sure that it's stamped, and then that way we know that hopefully we're protecting our employees. Okay, and like I said, never compressed oxygen, never carbon dioxide. Always make sure it's going to be just compressed air, and not blowing ourselves down, but actually blowing down tools or equipment or whatever, or surfaces if we're going to paint or something like that. Okay. Also, folks, just a reminder also that when we do it, we also want to make sure that we do a we also want to make sure that we do make sure that we have safety glasses on, preferably some type of, maybe even goggles, and also possibly even a face shield. Easiest place to to know about that is during the from the manual from the manufacturer, and whatever they tell us they want is what we're going to give them. Okay, so the easiest place is if you wind up buying a blowdown tool like one of these, like I said, a Husky, Cobalt, okay, depending Campbell, depending who's you buy. Just make sure you read the instructions that come along with it, because just like any other OSHA citation or standard, we're going to have to follow the manufacturer standard on this as well. Okay. All right, great, folks. So let's go ahead and move on. Let's go ahead and flip over to page 10 and 11 in the same book. So we're over on page field safety book, page 10 and 11, and there you'll see your hand signals. Okay, and we were talking about hand signals last week. If you look on your left, you'll see hand signals for forklift, and if you look on your right, you'll see hand signals for a crane, for crane. Okay. So there's both of them. You'll see that some of them are very similar. Okay. Also, in addition to that, another thing you want to keep in mind is look at the crane. Look at the upper middle. We talked about dogging everything down, and there's the dog down sign, right? Just basically putting our hands over our abdomen in an X formation, and basically, what are we telling the operator? Hey, let's go ahead, dog everything down, right? Let's bring down the load. Let's go ahead and shut everything down until we can reassess. Okay. And then, like we talked last week, is the crane operator has the authority to go ahead and not accept the load if they do not feel it's been rigged comfortably. They have the authority to stop work at any time. But not only do they have the authority to stop work, but they also have the responsibility to stop work if anybody in that work area, and that's as per the OSHA standard, that's as per the OSHA 1400 standards, that if anybody calls a stop work in the area of a crane, that crane operator's got to stop until they can reassess. Okay, until they can reassess. Let me ask you, folks. Anybody out there? Does anybody out there have employees that are non-English speaking employees that are possibly operating cranes? Okay. All right, so let me show you something really quickly, folks. Okay, I'm gonna show you where to find this. It's gonna be OSHA 4. It's gonna be OSHA 14, 1926, 1400, which is the crane standards. That's the new crane standards that came out about 3 years ago. Okay, and I want to go ahead and show you. I want to show you something really quickly. Let me get to the full. Let me get to. Let's see, subpart. Let me do subpart 1926, subpart CC, and let's do language. Okay, operator qualification and certification. Language and literacy requirements. I want to show you this because this is something that many people do not understand. Where is it? Let's see. Language literacy requirements, right? And basically what's going to happen is that the test has to be, if you look at it here, test right under this section have to be administered in a language that the operator understands. Okay? So it's got to be in the language that the operator understands. And then not only that, but let me pull up signage now. Not only that, but also in here, it's going to also tell us that the operator, it's got to be in the language in which they understand. So let's say if the operator is trained in Spanish, and then we have to have the signage in that crane is going to also have to be in Spanish. Okay, if that operator is trained in Vietnamese, and then we're also going to have that operator have that equipment in Vietnamese as well. Okay. And the reason being is that it's in a language. Here it is right here. What I was looking for right here, folks. There's the operator is qualified under this paragraph, right, to operate equipment that is furnished with materials required by this part that are written in the language of the certification. So what happens is the materials for the operator, if they had to be trained in Spanish, that means the equipment's got to have Spanish labeling. It can also have English labeling, but it must be labeled in the language also that the employer understands. Because if not, the belief is this: is that we're putting them in theory, we're putting them in a piece of equipment that they do not understand the instructions, warnings, and labels, since they weren't able to be trained in English. Does that make sense? Okay, good. All right, great deal, folks. Okay, so there's your hand signals. Okay, also, and let me show you really quickly, and OSHA again, OSHA subpart CC. Anybody who's got the 1926 book, the construction book, let me go to it, and it'll have all the OSHA will have all the subparts as well. Let me see if this is out of. Oh. OSHA will have all the subparts in the CFR. I don't know. I think I'm almost certain they have the electronic version as well, but they will have all the hand signals in the CFR as well. Okay, so if anybody has the 1926 book, you'll be able to pull them up out of the book and see what the signals are as well. Okay, and then let me see if this is it right here, but I don't think this is OSHA's. Okay, and this is roughly what the OSHA standards look like as well. Okay, so it looks more like that caricature drawing like that, and you'll see it. So there you go. That's the source right there, the 19 subpart CC Appendix A. I just don't think I think I was scrolling over those pages out of that CFR that I was pulling up, the actual government CFR version of it. Okay, so so it's in there, and like I said, all this is the thing with signage, folks, is that the hand signals have to be used, the ones that come with the crane, or the ones that are actually directed by ASME, American Society of Mechanical Engineers, and ANSI. Now they can, and employees can use any type of other signaling, but if they opt to change the hand signals, they must cover, and we talked about this last week, they must cover the standardized hand signals with what their hand signals will be, so that there's no confliction of opinion or resources inside that vehicle or near that vehicle. Okay. All right. So let's go ahead and move on, and let's look at the bottom of page 12. And then fueling, right? Just in case we have to fuel any type of heavy equipment, what do you have to do first of all? Stop and shut off that equipment, right? We want to go ahead and minimize the risk of any type of static electricity, any type of heat generation, or spark. So we went ahead and shut down and minimize that risk. Also, if the engines are hot and we need to be cool, we need to be fueling around that engine, and then we're going to have to probably let it cool for a while. We know nowadays, though, that most fuel sources, right, as far as refueling source or areas, are normally not near where the engine or any heat source is. Okay, so and then also we don't want to overfill it, right? Fill it adequately, but don't overfill it, and to keep any sparks or open flames away. And we're going to go back to any hot work not being done within 35 feet of a flammable. Same thing, not smoking, right? Not being on the phone or anything else that could produce a static or spark while employees are fueling a piece of equipment. Okay. And then, as you see, we have four different case studies on those 2 pages, page 12 and 13, just for you to read at will if you like. And then a middle resource, which is just talking about the risk of burns and the strength of gasoline as well. Okay. All right, folks. So let's move on. Let's go ahead and move on to Module 7, page 15, which is Section 2. We'll talk a little bit about center of gravity and tipping points on these types of equipment. So what are we talking about, right? And if you look in the green section of trade terms, center of gravity, what are we talking about? We're talking about the point at which around where the object's going to be evenly distributed, right? So that's that center of gravity. Keep it as balanced as possible in order to reduce or significantly or maximize the reduction of any hazards where that vessel or that vehicle might capsize, flip over, roll over, or whatever the case is. And then combined center of gravity, what are we talking about? Is the weight of two items or more. So it could be the weight of the crane or the lift, the forklift, or whatever the case may be, plus the center of gravity of the load as well. Okay. And then, of course, operator's compartment. What are we talking about? The control position, right? Where the operator will be operating. As we all know, we'll have a lot of safety measures in place. We'll have seat belts in place. We'll have controls. We'll also have overhead protection. Sometimes we'll have glass or plexiglass protection as well. So different types of protection that we'll have. Okay. And then if you look at safe operation of a forklift, what are we talking about is, common misconceptions, right? That cars drop, heavy equipment or fork trucks drive like cars or trucks, and they don't, right? The center of why? Primarily the center of gravity is different. Okay. Anybody care to guess out there? Let's say a typical Toyota forklift. Let's say one that you use like in a warehouse. I think it's an 8GU or something like that. Anybody care to guess what the weight is on a Toyota forklift? Or better yet, why don't you do this? Why don't y'all throw me a guess out there? Yeah, y'all are gonna. A few of you still are coming in, so a few of you, why don't you send me your weights as well? A lot of times these trucks, folks, just so you know, I mean the weight in these trucks is, you know what? As a matter of fact, I might have a manual. Let me see. A lot of times it's in excess of 12 to 15,000 pounds or more. Okay, let's see. Let's see if this one's got it right here. I don't think this one's got the weight of the truck, but a lot of times they'll wind up being in excess of 12 to 15,000 pounds. Pretty much, I'd say the best way to explain it, I explain it to people, is two King Ranch trucks, F-250s. You still have a Toyota forklift that's going to weigh more than that. Okay, so it is outrageous the weight that a lot of these pieces of equipment weigh. Okay, I'll pull it on the break. I'll pull it for you folks, and then and I'll give you I'll give you an actual answer. I'd like you to lay eyes on it. Okay. Okay, so things that we're going to talk about, right? And obviously OSHA has standardized. Folks, are y'all hearing me okay? I got a message that audio might be downgraded a little bit. Are you hearing me okay right now? Okay, good. Okay, great. All right. We as far as OSHA, right? We've talked about repetitively that we have to meet the OSHA standard. I know we've done this on a number of times, so let's do it one more time. I'm going to the OSHA e-tool for forklifts. And every time I go to this OSHA e-tool for forklift, I don't know if I discover more and more. I don't know if they're just continuously adding more and more, but I want to show it to anybody who's not familiar with it. All I did was Google OSHA e-tool forklift, and it's this first one right here, a powered industrial truck, right? So forklift is one of many powered industrial trucks. If you go back to the previous modules, it could be anything: a backhoe, a trackhoe, a skid steer, a bulldozer, a street grader. Okay, all of those. All-terrain, all of those are also considered powered industrial trucks or motorized construction vehicles. Okay, so I'm back here at the OSHA tools, and I just want to show you a few things. I mean, first of all, the powered industrial truck standard, it really just concentrates, the majority of it is on forklifts, okay, although it meets all other types of equipment. I want to show you the types of forklifts. There's 7 different types or classifications of forklifts. The terms are pretty much used interchangeably. I know that we did this once before. I just want to do it again because I want to show you where it's not going to be the type of the class, but we're gonna go to a lift code as well on some of them. Okay, so let me show you for an example. So we have different fork trucks, right, and these are all motorized. So we're looking at an electric forklift, class 1 or type 1, whatever you want to call it. Class 2 is going to be a narrow aisle or something that you would normally find more like in a retail outlet. Type 3 is a motorized pallet jacks. Non-motorized pallet jacks will not be counted as such because these are only for powered industrial trucks. Okay. Also, 4 is going to be our propane, our gas, our diesel, the fork truck with cushion tires. Now, type 5 or class 5 is going to be air-filled tires. It'll be the same type truck. It could be fuel. It could be diesel. It's going to be a combustion engine, so it could be liquid nitrogen, it could be propane, it could be diesel, gas, whatever the case is. But it's going to be on air-filled tires now. That's the difference. Now the risk is if we lose air pressure that we may lose some of our center of gravity. That's why the 4 and 5 are the significant difference between the two. And then we'll have like electric or internal combustion engines for engine tractors, and then any type of skid steers, RTVs, ATVs. As well. Okay, so those are the 7 types of forklifts. Now, let me take you to class 2. I just want to show you really quickly, folks. When we train an employee, we must train them on the class, okay, or the type, but also you may want to consider the lift code also. Let me show you what I'm talking about. Here you go. Now I'm in class, if you notice here, I'm in class 2, right, narrow aisle side trucks. And then not only do we have 7 classes, but only in this one class alone, we have 6 different types of lift codes. Okay, so what we've done is that when we add our form, our sheet, and I'm sending it. I think I sent it to y'all a couple of weeks ago. I'll resend it. We have our class type, and then we also add the lift code to it as well. Okay, so there you go, folks. If you have any questions, just find if you've got one in your workplace, just find what you got, figure out what type it is, and then once you figure out what type it is, and then you'll be able to come in here and figure out what type of lift code it is as well. Okay. Did y'all know this was here before? Let me know if you knew this was here or you didn't know this was here previously. Okay, mixed reviews. Okay, all right, that's fine. Okay, now in addition to that, what we're going to talk about right now is all the different rules. Let me show you where all these different rules come from. Things like loading, unloading, traveling, servicing, tipping. This is, if you look here in this OSHA e-tool, okay, and where I'm coming now is here where you see pre-operation, traveling, maneuvering. All of these tips right here, OSHA calls them, they're called recommendations and requirements. And they don't delineate to determine which ones are requirements, which ones are recommendations. So this is what we've done in our offices, since OSHA just puts them down as recommendations and requirements. Like here where you see I'm talking about it right here. If it doesn't specify, we're going with we've decided a few years ago that we're going with all of them being required, okay, since they don't specify which is which, okay? So here you go, and these are things that we'll start talking about, right? Fluids, pre-check inspections. We'll start talking about electric forks, internal combustion forklifts, liquid propane, and then it'll start going into operation inspections. It'll start going into removing it from service, maintenance. Okay, and then we'll also if you come back up here, you'll also get to traveling and maneuvering as well. There you go. Okay, potential hazards. Recommended practices, requirements as well. So there's a whole litany, folks, of different standards that are like here that you see here that are referenced. And this is what I tell everyone: if you find a hazard in here and it's referenced, there's your citable offense. Okay. So you've got OSHA's done so much of the work for us. All we need to really do is spend a little bit of time. And many of the e-tools, but particularly this one, the powered industrial truck one. All right, so let's go ahead and move on, and we're going to talk a little bit about it, right? Safe operation. So let's talk about the safety rules when we're doing when we want a safe operation of a lift truck. I'm at page 15, module 7, on the right-hand column, about midway down. Things we want to do, right? Always check the capacity of the load chart mounted on the machine before we're going to operate it. We want to know what it's capable of picking up, and we also want to know at what angles we can pick it up, right? In addition to that, never put any part of our body into the mast or the structure or between the mast. When I'm talking about the mast, for anybody who's not familiar, this is what I'm talking about right here. I'm talking about the drive, either belt or chain mechanism, right here behind this back rail. Okay, let me get my mouse out the way. So this is what I'm talking about. The mast is all this right there. Okay, you have your forks, you have your back rest right here, and then you have your mast. Okay, all right. In addition to that, also understand the limitations of the forklift. We need to know what the maximum lifting capacity is. We would need to know what the maximum height capacity is. Not performing permit, not allowing anybody to ride the forks or even ride on it. Unless I tell people, every seatbelt, you get one butt. That's what I tell people. So you got one seatbelt, one person can ride. You got two seatbelts, two people got ride. Well, what do we have in it? One seatbelt, right? So no one else rides that truck in any form or fashion, okay? Never leaving the forklift running or unattended. We talked a few weeks ago, and we talked about what unattended was, right? So let's go to the OSHA standard so I can pull it back up one more time. So I'm going 1910, 178 right here. This is the OSHA standard for forklifts. And what I'm going to do is I'm going to pull up the standard and I'm going to word search, Control F if you're on a PC, right? Command F if you're on a Mac. And I'm going to do the word unattended. Okay, so there you go. Here's the standard, folks. Let me just move this window that you can't see out of my way. Okay, so when a powered truck is left unattended, right, unload engagement, what do we have to do? We have to fully lower the forks, right? We have to put the controls in neutral. We have to shut down the power, and then we also have to set the brake. Okay, if it's an incline, and then we'll probably have to be doing some chalking or blocking as well. Okay, but look at this. What's the definition of unattended? Right here, and I know we talked about this a few weeks ago, but you see how many times I'm coming back to this. What is it? Anytime that powered industrial truck's unattended is when we're more than 25 feet away. So if we're greater than 25 feet away, but we can still see it, it doesn't matter. It's unattended, okay? Not only that, but anytime it leaves our vision, our view, it's unattended. So I tell people, if you walk on one side of a bay door and you cannot see your fork truck, you can be 5 feet away or 10 feet away. If you cannot see your truck, and then it's unattended, okay? We must be able to have visual contact on it at all times and be less than 25 feet away. Otherwise, we have to follow the policy on unattended vehicles, okay? Great. And then in addition to that, never, like we said, never carrying passengers on the forks. And then we want to pay special attention as well, too, right? Safeguards for pedestrians. These are things that we have to do. We have to always look at the direction of travel. So if we're going forward, we look forward. If we're traveling backwards, we're looking backwards. But we're always looking in the direction that we're traveling in. We're not going to drive the forklift up to anyone standing in front of the forks. Let me ask you a question. How many of you have ever seen where somebody is guiding a forklift and they're standing in front of the load? Has anybody ever witnessed that? I've witnessed it multiple times. Yep, exactly. Well, there you go, right? We're not allowed to do it. And let me tell you who's going to tell us this. It's going to be in the OSHA standard. It's going to be it's going to be the e-tool. it's also going to be in the manufacturer's specifications, okay? It's going to tell us don't drive it. So what's the easiest thing to do? Get somebody to get out the way. Let me ask you a question, y'all. How many times have you noticed that when somebody's backing up a truck or a trailer and they get behind the trailer, you don't need to be behind the trailer. We need to be on the side of the trailer where the operator can still see us while they're trying to maneuver that piece of equipment. Would you agree with that? Yep. It's just a bad habit that we have, and we just kind of have to break it, right? It's that culture, right? Okay, great. So, in addition to that, what else, right? We need to make sure that personnel stand clear of the rear swing. So, if that piece of equipment has a swing radius, we need to be careful. Sometimes the swing radius will be on the back, and then if we're traveling in reverse, the swing radius may be on the front, right? So we want to always be cautious of that. Also, exercising a particular care anytime we're going to cross aisles, doorways, other locations where pedestrians may be in the path of travel as well. And then we always have to use a spotter when we're moving an elevated load, right, with a telescope and forklift. Right? Why we're going to use it? Because either it's going to obstruct our view or it's elevated, and then we have to worry about overhead hazards. Okay, so that's why. So even though we're putting, if you look at those sky tracks right there, perfect example on page 16. Yes, we've elevated the load, so we haven't obstructed our view, but now we have to be concerned about overhead hazards that we may miss. Okay, and that's why. And then when working in a storage room, right, or a warehouse, with racks, we're never going to work on aisles. We're never going to work on aisles, right, when somebody's on the other side of the rack. You ever been to Home Depot or Lowe's, folks, or Truck and Tractor, and you notice that when they go use even those narrow aisles, those type 2s, you notice how they block off the adjacent aisles to it, the aisles that are parallel? Yeah, so okay, good. So a couple of you have, huh? Yeah, and that's what they'll do. They'll go ahead, even with those narrow aisles, because if they accidentally bump that um, the storage racks, it could be possible that something could fall, and it could be also possible that we collapse. We collapse them, right? So we need to make sure that at least in the adjacent aisles, next to the parallel aisles next to it, that we need to make sure that we also control that area as well. Okay. Um, okay, good. So, and then let's talk about a little bit about general guidelines, right? Anytime we're using a forklift, what's its main use? It's to transport, right? Heavy, bulky, large, awkward loads that aren't always practical to do manually, right? So, I mean, that's basically what we're looking to do. So let's talk about traveling with loads a little bit. And look, folks, like I said, let me go back to I want to go back to the OSHA tool one more time just to show you that all this information that we're talking about is also in this OSHA tool. So, like I said, right now, if you look at it, I went to the traveling and maneuvering. So much of what we're talking about right now on page 16 and 17 and 18, just so you know, it's here in this part of the e-tool. Okay. And then I'm gonna show you one more thing. As a matter of fact, let me show it to you right now before we even move on. And this is one thing that I tell people. Let me use the word yield. A lot of people don't realize. And the thing is, OSHA put this in here. How many times have you seen? How many times have you seen that in the workplace they tell us that the employees have to yield to the forklift, and it's going to happen, right? I mean, we know it's going to happen. Would most of you agree that they tell us that the vehicle's got the right of way? Okay, so check this out, right? So now I'm looking at pedestrians. Look at the right here in the e-tool. Okay. And here's the problem. Like I said, it says recommended and required. Which one is it? They don't delineate, right? But there you go. Yield right away to pedestrians. So what I tell people is just be ultra cautious. I mean, we know operations is going to come first, right? Yeah, a lot. You're absolutely right about that, Jason. A lot of people say, oh yeah, the forklifts always got the right of way. Well, pedestrians should, but the biggest thing is we want to be cautious of it to make sure that employees aren't in the way. And if they do see an employee, of course, we're going to stop, right? But the biggest way we control that is don't be in the roadway, don't walk, right? We may have painted guidelines where pedestrian traffic is going to walk. We may have sidewalks or whatever the case is. Okay. All right. So let's go ahead and keep on moving through with the traveling with loads. So first of all, we want to always travel at a rate of speed, right? With a load, right? We want to make sure that we travel at a safe speed. We never want to travel with the load raised. Now we say we never want to unless you're doing something like a sky track or something like that. Normally when we would have a raised load. But when it's a fork truck or if it's any other type of vehicle like that, we want to travel with it as close to the ground as possible. Really, the rule of thumb is really keeping it 4 inches or below or closer to the ground unless necessary to pull it up a little bit. Okay. Also, staying alert and paying attention. Right, watching the load and the conditions ahead, and then making sure that we alert others that we're coming. And a lot of times the horn, the flagger, right, will be a good way. And of course, always applying the brakes as well. Avoiding sudden stops, abrupt changes in direction. So make sure that we carry that load as cautiously as possible, with as much of a smooth transition as possible to prevent any type of toppling and shifting. Also, if we're traveling with a telescopic boom forklift, we want to make sure that that forklift that boom is fully retracted, right? So we want to try to pull that boom in all the way. Look at the SkyTrack again, and you'll see what we're talking about in the bottom left-hand picture. Pull it in as close as possible to the vehicle itself, and travel with it in that capacity. Okay. Also, it may be a regular fork truck. It may be a Type 4, a Type 5 fork truck that may push out. It may have they call them an outrigger actually, okay, on a forklift. So let me see if I can pull one up for you really quickly. And someone and I just recently had this conversation. So let's say Crown forklift outrigger. Okay, so this is what I'm talking about, folks. For anybody who's not familiar, when you see this right here, okay, and they can push and pull, they call that an outrigger. Okay, so just so you know. Great. Okay, so let's see. Of course, traveling the smoothest route possible. Make sure to try to prevent as many rough surfaces from traveling on as many rough surfaces as possible, so that we can better control our load and minimize the bounce. Traveling with our long loads, we know can present certain hazards as well. So what do we want to do is that we want to be cautious of it, right? We want to, we might have to make sure that we watch the distance. We may have to add more distance to it, and give a little bit more space, because we may have a little bit more bounce in that point of travel. We may have less load of balance as well. So make certain considerations for it, right? Also, to prevent any type of slippage, we want to make sure that we secure the long loads to the forks as well. So we may have to either lash them down or strap them or ratchet them down. Anybody who's not familiar with latching, lashing, we talked about it last week. Let me show you real quickly. I'm going to look it up for fork truck. If not, I'll just look it up for a vehicle lashing. And basically, I'm talking about these ratchet straps that you see and just lashing it down. Okay, so let's do this. Let's do vehicle. Okay, this is what I'm talking about, folks. We talked about this on Tuesday. Is basically lashing down or tying down. Um, is what I'm talking about. Okay. Okay, great. And then in addition to that, right, we also know that the forklift may be used to carry pieces of rigging equipment as well. So what are we talking about? If we use that method, we're going to wind up putting the slings either around the forks or a spreader bar. Biggest thing is we may have to use a hoisting device also. So the biggest thing is making sure, reading that instruction manual, right, that manufacturer's manual, to see what if we can go over the forks, to see if we have to make any considerations, to see if we need to put some type of hook in place, an attachment that's made by the manufacturer. Okay, so that's the biggest thing. So here's a perfect example of what I was talking about right now, like a hook or something like this. So just be cautious of it. Okay, some manufacturers will tell us that we cannot strap rigging around those forks. Okay, so just be cautious of it. In addition to that, also, what happens in some cases, we may have long loads that maybe snake through openings, so they may be narrow or more than wider. So we just got to make sure that we travel with them as safely as possible. We may have to manipulate it in different loads. We may have to drop it, or not drop it, excuse me, lower it, and reposition as well if necessary. Okay. Also, we want to position the forklift right at the landing point, so when the load's placed, it's going to be where we want it. So watching that path of travel to make sure that the load is going to be as most conveniently and safely put in place where we actually need the load to go. And then, of course, with the forklift, when we're in the unloading position, we're going to go ahead and lower the forks, right? We're going to keep them. We're going to keep them in a horizontal position. Another thing we're going to do, and I think it's a few steps down, is once we're done, drop them to the ground. Okay, less of a trip hazard, less of somebody harming themselves. So making sure that we keep them as low to the ground as possible, or all the way down on the ground. Okay, so then you go into it. We're talking about special care needs, right? When we're taking place, when we're doing elevated loads as well. We also want to make sure that some forklifts, they'll have their own leveling device, right? So we want to go ahead and make sure that we take all considerations, especially newer forklifts. So we definitely have a lot more technology now with newer forklifts. And for anybody who's wondering, we're still on page 17 to the upper right. It's just a lot of bullet points that we're covering, right? And then, of course, what's one of the biggest safety hazards in elevated load placement is going to be poor visibility. We need to be able to make sure that we can see with the load. If we can't see with the load, what's going to happen? We're going to go ahead and pull somebody in and have a signal person to help us, right? And to help us position the load. So it's not always just traveling, folks, but sometimes it's going to also be traveling with the load and or loading and unloading the load as well. And then, of course, in addition to that, use taglines, right? And make sure that we use taglines where necessary as well. And then, of course, keep in mind that when we use taglines, one of the main considerations that we want to make with taglines is that we use preferably non-conductive taglines. And folks, this is for any tag line, whether we use a crane or a forklift. Don't have any knots in it. Don't put any eyes in it or loops or anything. Just one straight line and long enough for employees to safely operate with it or try to help assist to balance the load, but not so long that where it may become a trip hazard or get them wrapped up and drag them or pull them up hazard. Okay. And then if the forks start to move, lean, sway away, what are we going to do? We're going to stop immediately, right? We're not going to stop abruptly, but we're going to go ahead and stop immediately as immediately as possible. We're going to go ahead and lower the load slowly, and then we're going to go ahead and reposition. We're going to go ahead and reestablish our position and go ahead and try to take another crack at that load if possible. Okay. If not, we may have to get with management and supervision as well in order to, we may be using the wrong type of equipment to make that lift, or we may have to make certain considerations in order to safely move that piece of equipment or material. Okay. And then, of course, never attempting to rig an unstable load with a forklift. So we want to make sure that we're going to always respect that center of gravity. Okay. I'm going to show you a couple of videos. I think I'm going to try to show you one live one if I can. Anybody in here has everybody seen that China video recently where the lady got crushed by the forklift trying to hold it down, weigh it down? Had you seen that or had you not seen that? Yeah, it's sad, huh? Yeah, it's sad. I think most of us saw it. So I'm going to be sending out the link to that, folks. I'll put it in the email if that's the case. It looks like most of y'all have seen it. So I'll go ahead and send out the link for that. Okay. And then anytime we're carrying any type of cylindrical objects like oil drums, we want to keep the mast tilted toward the rear, right? That way it keeps it against that backrest and it keeps it from rolling off. Not only that, folks, a lot of times when we carry items like drums and stuff, we may also need a pallet. Okay, so you just got to watch it because we may not always be able to just put it on the forks, especially if it's not properly balanced, or we may need to ratchet it in or strap it in to secure it somehow to make sure to prevent it from moving. Okay. So just keep that in mind. And then, of course, any tipping hazards, right? You know, what's the three main load causes of something tipping? First of all, the load's too heavy. Second of all, it's too far away from the forks, right? We didn't get the right center of gravity on it. And third of all, it's the way they're erratically operating that piece of equipment, right? So those are the three greatest hazards when it comes to tipping. And then on the next page, if you notice, what it'll do is it'll show some examples of stability control. Okay, for your forklift. Okay, where when it's down, when your boom is down, and this is pretty much more like a SkyTrack, right? If you look at it, if you look at these three, it's basically an illustration of what a SkyTrack would look like. And the way you know that is because if you notice that the boom is attached to the rear of the structure of the vehicle, so that's why it's a a SkyTrack or that type of equipment. Okay. And you see how that center of gravity, it goes moving, right? Depending where the weight is, how it's distributed, and that's what the risk is. So the higher we go, if you notice what we're doing, is the higher we're pulling that center of gravity. Okay. All right, great, folks. So let's keep on moving. We're at page 21 on section 7. Okay. And what we're going to do is we'll go ahead and push through this little bit of crane, and then we'll go ahead and take a break there, and then we'll take a break really close to 7:30. When we come back after 7:30, and then we're going to go ahead and roll straight through Module 8 and see if we get into 9 tonight, get through it. It's going to be really close, folks. Y'all know we try to keep every module independently, but it hasn't been working too well lately, just because we've got the modules. We haven't been able to end them right on the module because of the timing. Okay. All right. So let's talk about this last section now. And what are we talking about now? Now we're talking about cranes, right? And if you look at it, the only trade term that they've pointed out is outrigger. If you look at your figure on page 21, for anybody who's not familiar with what outrigger is, it's those jacks that you see there. Okay. It's those two jacks that you see between the second set of wheels and the the first set of wheels and the second set of wheels. Okay. And the one all the way to the back of the vehicle. And what happens with those outriggers, with anybody who's not familiar, they have hydraulic that will go down, that will lift that vehicle. And they also have hydraulics that will push out. So they will push that outrigger out depending on where the manufacturer tells them to set those outriggers, depending on the load or the weight. And then oftentimes they may tell them to push them all the way out, or if an operator is not certain or it's not specified, and then you always go all the way out, okay, on those outriggers. All right, so let's talk about this for a minute, and let's talk about personal safety, right, of riggers, and hoisting operators. Okay, so let's talk about some common sense rules here, and let's talk about safety practices that we should observe. First of all, look at number 1, like we were talking about. What's number 1? Always reading those manufacturer specs, right? Those manufacturer's instructions, and whatever they tell us, we do. We check, we do all our pre-operation checks, we follow the guidelines, we do our periodic inspections, and ultimately we make sure that we have the information available for the operator, right? Also, determining the weight of all loads before we rig them. We have to know what we're lifting, folks. It's the only way we know that we're, at what the load chart should be on a crane, and also what type of rigging we're using, and to make sure that our rigging setup is sufficient as well. Okay, our hitch is sufficient as well. And I'll show you all the different hitches in just a minute, folks. I showed them to you already: vertical, basket, and choker, and I'll show them to you again, okay? And the bridle, and I'll show them to you again. Also, determining the weight of all loads, like we talked about right now, knowing the safe working load of that equipment and the rigging, right? We don't want to exceed the load of the limit of the rigging or the equipment itself. Also, examining all equipment and rigging before we use it, prior to every use. It's not just every shift, it's every use, folks. So you grab those slings, want to keep an eye on them, right? Now, we may be a more detailed inspection prior to every shift, and that's one of the reasons. Have y'all noticed, folks, how many of you have noticed how little we use chain these days? That we use wire rope and synthetic rigging so much more often now. Have you noticed how little we use chain now? So let's talk about why, right? The 3 greatest hazards with chains are most often. Let's talk about what they are. First of all, the weight. So it becomes an ergonomic issue, an ergonomic nightmare, right, with the weight. Second of all, pre-inspection on a chain, it's going to have to be done link by link. The old adage, right, or the old saying about a chain is only as strong as its weakest link. We have to check every single link to make sure that it's not twisted, it's not stressed out, it's not bent, okay, whatever the case is. And then also, in addition to those two, is the ergonomics, the weight, the inspection of link by link. And sorry, folks, I totally went blank on the last one. I'm thinking about it in a second. All right, sorry. I think I blended the two between the weight and the inspection. So let me think about it, and I'm gonna get back to you on the third one. Okay, sorry about that. And then let's see. In addition to that, oh, I'm sorry, and that's the last one, is actually having to check it link by link. That was the last one. I'm sorry about that. I did blend them, okay? Okay, and then also immediately reporting defective equipment, right, or tagging it out, getting it out of service. I tell people, if you're going to tag it out of service, you should get it off the work site, folks, or at least get it out of the work area, okay? And then of course, stop hoisting or rigging operations anytime the weather gets rough over 25 or 30 miles an hour. We gotta stop lifting operations. Now, let me tell you, folks, it is not the OSHA standard that tells us this. OSHA standard only tells us we have to stop operations after 25 miles an hour or 30 miles an hour when it is employees being hoisted. Okay. What happens is that there is a publication out, and let me show you where it is. Okay, I'm going to show you where a couple of them are. Let's say OSHA subpart CC, cranes, right? Let's do hoisting personnel. Okay, let's see, might be in the wrong. Okay, so here it's gonna. Here's your OSHA. This is your CPL, your compliance directive. Okay, and it'll be one directive for us, and then let me pull up the actual standard itself. Okay, so that one's talking about changing winds, but let me pull up the speed of the winds now. Okay, I just saw it right here. Let's see. Okay, so here you go. For hoisting personnel, right, requires that if wind speeds sustained or gusts exceeds 20 miles an hour, okay, employers have to not hoist personnel unless a qualified person determines that it's safe to do so. So there you go. There's where OSHA says it. Okay, and it's 20 miles an hour. I was thinking it was 25, but it's 20 miles an hour on employees. Now let me show you where it's going to say it now in the. Let me show you where it's going to say it now in for hoisting materials or equipment. Okay. So materials or equipment now is going to be in the Department of Energy, crane lifting wind. This isn't normally the what you call it that I use, but let me see if it's in here. Okay, here you go. And since I have manufacturer's instructions, right, regarding maximum wind speeds, operations undertaken under over 25 miles an hour, and then what's going to happen? Same thing. It's going to have to be evaluated by a qualified person. Okay, so 20 miles an hour with personnel, right, is the limit unless a qualified person deems it safe. 25 miles an hour now with equipment and materials attached as per the Department of Energy. All right. So let me ask y'all, folks, anybody who's on the line right now, what happens if an employer has a qualified person determine, hey, wind speeds are 30 miles an hour, and they deem that it's safe to lift employees and or safe to lift materials? You think we got a problem? The qualified person's got a problem on their hands? Yep, absolutely, right. So there you go, folks. There's the two standards. Okay, like I said, there's three standards. Let's get them straight. OSHA tells us personnel because they're worried about the people, right? Department of Energy, and OSHA incorporates it by reference, tells us maximum wind speeds for picking up any lift. And then remember, ultimately, what do we have? The crane manufacturer's instructions, right? And the crane manufacturer is going to probably tell us 20 to 25 miles an hour, folks. All right. Okay, great. All right, so we got all that. So let me go ahead and keep on going with the bullet points now. I'm up in the upper right hand side of page 20 now. Safe working loads, right, for all hoisting and rigging equipment. What are they going to be based on? Ideal conditions, right? But this is everything, folks. If we're talking about safe working distances, it's ideal conditions. If we're talking about noise protection against noise, ideal conditions. Respiratory protection, ideal conditions, all right? The same thing with rigging and the same thing with a wire rope. It's going to be under ideal conditions, all right? We want to avoid any type of rapid swinging or suspension of loads. We want to make sure that, equipment, that we don't side load equipment as well. Side load equipment, for anybody who's not familiar with what it is, let me show you what I'm talking about, okay? So this is what we're talking about right here. This is a center of gravity is here, right? So this is traditional load. This is a side load. We're picking it up from another surface. Let's say this text box right here is a surface, and we're pulling. Think about the extra slack we have here. What happens when we pull off of this ledge? Now it's going to drop, right? It's going to go from here and it's going to drop down here suddenly. Okay, and that's why we don't want to side load that, and we don't want to put a tension on the crane as well. Okay, and that's whether it's an overhead crane, that's whether it's a mobile crane. We don't want to side load. Okay, and that's why. Okay. So let me keep on going here. We talked about side loads. Let's see. Also, safe working loads, right, for hoisting equipment, or they're applicable only to freely suspended loads, right? So, biggest things we want to remember is that we're talking about single loads, right? Freely loads. Also, ensuring that safe workload of equipment is not exceeded. So, whatever the load chart is telling us for that crane and for the rigging is what we're going to follow. We talked about that the other day also, right? A critical lift. A critical lift, if you look at your crane on the right-hand side, that link belt that's on the right-hand side, let's say if in that position that crane is 100 tons, that means that in that position on the short stick, meaning that the rest of the boom is in like you see it there, that means if it's a 100-ton crane, that means that in that one position and properly outrigged, it should probably be able to pick up 200,000 pounds, 100 tons. So that means that a critical lift would be 75 tons, okay? So it would be 150,000 pounds. Anything above 3/4 of its capacity would wind up being a critical lift. But at the same time, let's turn around and say that we only use, I don't know, slings that are 15,000 pounds apiece and we have 4 slings. We're going to calculate it on the weight of 3 slings because we're going to count 1 is 1, 2 is 2, 3 is 3, 4 is 3, okay? I think we talked about that, if I'm not mistaken, about 4 weeks ago. When we count 4 in a bridle, and I'm about to show you what I'm talking about for anybody who's not familiar. Anytime we count slings in a bridle, let's say if we have 15,000 pounds, we're going to multiply by 3, whether it's a 3 or 4 leg sling bridle. It's going to be 45,000 pounds, and it's going to wind up being 75% of 45,000 pounds, which I think is going to put us right around 37.5 or something like that. Okay, so whatever 75% of, actually, I'm sorry, it'd be less than that. It'd wind up being like 32.5 would wind up being the critical lift moment. Okay, it'd be 75,000 pounds of the lesser rated of the two, whether it's the crane or whether it is the rigging. Because at the same time, let's take that same rigging of 45,000 pounds, and if we take that rigging now and we boom out this stick 150 or 200 feet, we may only be able to pick up 20,000 pounds with the same crane. So now if we do 75% of that stick, now look what we're looking at. Now we're looking at 7,500 to 15,000 pounds, whereas the rigging now is a stronger component of the two. Okay. I remember we talked about that a few weeks ago, didn't we, folks? Do y'all remember that when we talked about critical lift? Okay. All right. And then anybody who's not familiar, what we're going to do is we're going to pull up a map or do a drawing of it and kind of show everybody. And what I'll do is I'll probably show you as soon as we come back from the break. I'll probably just show you a quick overview of it. Okay. All right, great. I'm going to get us a break, folks, in about the next 5 minutes or so. Okay. And then in addition to that, also, what are we talking about? Equipment load ratings, right? Only extend to the hook, block, the slings, the equalizer beams. So what happens is load ratings are for everything, right? They're for any attachment, any component of the crane itself, or any rigging equipment as well. Okay, the most modern cranes are equipped with outriggers, like you see in the right hand side. That's what we're talking about. We're talking about outriggers, and that is on a hydraulic outrigger. And then we'll also have a. Let me show you the other outriggers now. Let's see. And mostly it's almost always a mobile crane that's got them. So let's see. Crane outriggers. Let me show you. These are hydraulic out and down, and then we have the 45s. So let me show them to you. Okay, these are traditional ones like we're talking about now. And then let's see. Let me do a cherry picker. 25 ton. We may have some like these. That these, if you notice, they just go straight down. Sometimes they push out, sometimes they don't. Okay, depending on what the capacity of the crane is. And then let me pull up the last ones for you. They kind of swing out. They pivot out. Let me do a grove here. For anybody who's not familiar with what I'm doing is I'm pulling up a particular crane. Here we go right here. That's what I was looking for. These are the last ones right here where they kind of span out, okay? So there you go, folks. So those are your different types of outriggers, okay? Okay, and then working around power lines, right? We've talked about this over and over again. Power lines, folks, this is the biggest thing I'm going to tell you, is that we have to stay away from those energized power lines. We have to stay at least 10 feet away from energized power lines if they're under 50,000 volts. If they're over 50,000 volts, we have to stay at least 20 feet away, okay, from power lines. And let me show you really quickly. Let me go to the OSHA standard again. Let's go to OSHA crane power lines. And let's go to table. I think it's table A2 or something like that. Let's see. Okay, here you go right here, folks. Table A. Here are the distances, right? Under 50,000 volts, we have to stay at least 10 feet away. Okay, from 250 to 500 to 250 to 200, 15 feet away. But we normally jump straight from 50,000. And if we're not sure, we stay at 350, which is 20 feet away. So how many of you have heard that either we say 10 feet or we say 20 feet? That's why, folks. Okay, and then it goes on to even give us the calculation, which is 0.4 inches for every 1,000 volts over 50,000 volts from that 10 feet. Okay, but there's the table. When in doubt, and that's where you have it. It's in the crane standard. It's in the 1400 crane standards, right here at 1408. And it's also going to be in, I think it's subpart V or subpart R, which is the electrical standard as well. In general industry, it's going to be there in construction as well. Okay, so we'll have it on both. Okay, so things that we're looking at, right? And let's just roll through these really quickly and grab a break. How we're going to go ahead and hopefully minimize the risk of any energized hazard. What are we looking at? Non-conductive barricades, right? First of all, is not using like metal but parade barricades, but maybe using wood or some type of plastic, like K-walls or something like that made out of like plastic barricades is what I'm talking about. Also controlling the load using tagalongs with non-conductive, with either synthetic strap or some type of rope as opposed to some type of wire rope or anything, right? Also, the qualified signal person is going to be the only person who's going to be determining distances. Okay. The person responsible for operating is also going to alert and warn the crane operator and any persons around them anytime that we're getting close or adjacent to any electrical hazards. All non-essential personnel is going to be removed out of the crane area. This is anytime we're near an electrical hazard where we may be having to work around live or exposed lines. Okay. Also, no one's going to be permitted to touch the crane, right? Of the load other than the signal person. Okay. Why are we doing that? We're minimizing the risk of anybody being shocked or electrocuted, right? And then it goes into if the crane comes into contact, best thing the operator can do is this: stay in the crane cab, right? Don't allow anyone else to touch the crane or the load. If possible, try to back off of the line if possible. They're going to stay in that cab unless there's a fire, unless there's some substantial risk where that employee or that operator is no longer able to stay safely in there. We're going to contact the power company and our supervision, right? And what's going to happen? That operator, the only time they're going to leave it is they're going to jump they're going to jump from the vehicle itself straight to the ground. They'll never make contact with the vehicle and the ground at the same time, and either they'll shuffle or they'll hop out of there. I've got that in a video. So one of the videos that I'll send you tomorrow to read up on, or later on tonight, I'm going to go ahead and send you some links on some crane safety and some rigging safety, and it's going to cover all this on what we just covered. Okay, so there's all your different hazards, and then ultimately the last one is we have to be responsible to know what kind of underground utilities, right, as far as like gas, oil, electric, telephone lines, sewage, anything that's underneath the crane. Now, this is one of those circumstances where the OSHA standard says that the host facility or the host employer shall verify all underground utilities and ground operation, ground conditions, and advise the crane company and the operator. But the OSHA standard also, right here in the crane standard, says that we as crane operators or the employer must also verify that that those reports are correct. Okay. Also, electrical lines, we also have to be cautious of like high frequency transmitters. I'm talking about like RF transmitters, items like that, right? Cell phones, radio antennas, satellite, stuff like that. Okay. Also, structures and buildings, excavations, bridges. We need to make sure that we're aware of where the conditions are and our proximity to it. And then ultimately, and the last of all, we have to ensure that, like we said, the ground conditions can support the crane. Also, that we check that there's a safe path to move that crane around, and then making sure that the crane can rotate, right? And in areas in the quadrants where the lift's going to be, and where all the outriggers are as well. Okay, we're definitely going to protect. When we're talking about an outrigger, we're going to talk about protecting. You want to make sure that you're protecting within between the superstructure and the outrigger. So if you go back to the page on page 21, when I'm talking about the superstructure and the outrigger, I'm talking about the backside. Do you see where the crane swings? Okay, on page 21 at the top, that link belt. We don't want any employees being pinched. And the most common place to be pinched, and you'll see this, I'll send you some videos on it, is between the a cab turning around and spinning and where those outriggers are. Okay, I'm going to send you about 2 or 3 videos over the course of tonight and tomorrow that's going to go ahead and demonstrate all that as well. All right, so let's do this, folks. It is already 7:35, so I'm 5 minutes over. Let's take a break. Let's take 10. We'll reconvene at 7:45. Let's say 7:45, 7:48, somewhere around there. We'll kick it off and we'll run it for another full hour. Okay. Any questions so far, folks, or everybody okay? Okay, great. I'm gonna blank the screen and then I'll come back at 7:45. Turn the screen on. Then we'll wait another couple of minutes and we'll kick it off. And we're gonna be going to section 8 to module 8, and we're gonna be talking a little bit about concrete. Okay. Thank you. Hey everybody. Okay, we're back. Okay, let's go ahead and get it cranked out, and we're gonna go ahead and push through for another hour. Okay. Let me open. Hang on one second, folks. I want to show you something. This is a. If you see here, this is a Nissan forklift. Okay. Look at this. 8,500 pounds, and its a maximum lift capacity is 4,400 pounds. So almost twice as much. Most forklifts, a lot of them will come. They'll be about half, about 1.5 to 2 times normally as much as their lifting capacity. Okay, Toyotas tend to be a little bit less. So let's see where this one is. Battery weight. We're looking at this one. Let's see, truck weight here. Look, 8,500. Excuse me one second. I'm sorry. I don't know if you can see me yet. Give me one second. Okay, folks, can you see that screen okay? Okay, you see it right there? The total truck weight is 8,500 pounds. Okay, excuse me, 8,250. Okay, and look at the capacity on it, 3,500 pounds. Okay, which is pretty much the max capacity on it. So just to kind of, and look, and that's 3,500 pound capacity right on this fork truck. Now imagine a 6,500 pound fork truck. What are we talking about? Probably 12,000, 15,000 pounds. Looks almost the same, right? And then and I'll show you what I'm talking about. Let's see. I'll show you one more picture, and then we're gonna move on. Okay, right here. Here we go. So very little difference in what we normally see. So let me go ahead and show you what this 6,500 pound capacity fork truck looks like. There you go. How many times do we see that in the workplace? Okay. So just be cautious. I think that one right there is about it lifts 6,500 pounds. I want to say it's like 11,000 pounds or something like that. So okay. All right, great folks. All right, so let's move on. We're at module 8 now, page 1. We're going to talk about concrete hazards. We'll talk about some illnesses. We're going to talk a little bit about tilt-up construction. Okay, and let's go ahead and get moving, folks. So cement, I mean, we all know what cement is, right? I mean, it's a combination often of like ground lime, iron, different minerals, right? Chemicals in order to build cement or concrete. Chemical dermatitis, what are we talking about? It's a skin condition, and it's caused by contact with fresh concrete. And basically what it's doing is it's a chemical contact, but it's also drying out our skin as well, okay? And then guide, right? Basically what we're looking at, steady or guided load, right? That is laterally stable. So I'll show it to you in a few months. And then of course lanyards, which we all know what we're talking about, right? Basically part of our personal fall arrest, mortar mix. We're normally talking about it's like Portland cement mixed with aggregates of sand or lime, right, and water until we get the combination that we need. A lot of times we know where we use mortar is to go ahead and adhere like brick and block. To do stone is usually when we use mortar, okay? And then post tension. We're talking about as far as reinforcing concrete, right, with embedded cables or tendons in order to keep slabs together. Okay, so I'll show you a photo of it as well. Precast, a concrete member that's cast or cured, away from the concrete site, construction site. So what I'm talking about like tilt-up construction, which I'm going to show you in a few pages from now. Perfect example of precast concrete also. Because a lot of times now it's like concrete walls that are coming in already built and just being assembled. Components of bridges also. You'll notice how a lot of bridges used to be built on site, right? Many of them now come in. Sometimes not many of them, but sometimes they'll come in now and set up pieces, and we'll just start assembling them or putting them in place as we go. And then, of course, pre-stressed, right? It's a method of reinforcing concrete as well, with cables and tendons as well. Just kind of like post-tension, and then we have pre-stressed as well. Reinforce the structure, what are we talking about, in order to resist loads and give additional working load support as well. Respirator, we all know basically what a respirator is doing, right? It's going ahead and filtering out the impurities in the air, the particulates in the air, in order to us to be able to maintain better air quality. Mainly when concrete work, we're talking about air purifying respirators, obviously, as opposed to air supplied respirators. So we're talking about cartridge based half face, full face, or dust mask. And in order to pull impurities out of the air, in order to pull media out of the air, and capture it inside of cartridges or filters or the mask itself. And then, of course, scaffold, we all know it's a temporary elevated work surface. Screeds, you're going to see them in just a moment, folks. What it is, it can be manual, it can be motorized, straight edge tools that we use in order to smooth out concrete surfaces. And then shoring, what are we talking about? Props or posts or timbers, right, of material that we're going to be using in order to maintain the structural integrity of excavations. And then, of course, silicosis, right? We're talking about now, talking about the inhalation of dust and therefore affecting our lung system and our respiratory system. Of course, slab, we're looking at section of concrete, right? And what are we talking about? Normally, like a concrete pad or something like that, something we'll be putting on a foundation, basically. Slab on grade, we're talking about a ground supported concrete slab. It's normally used for foundation system now. And then subgrade, soil prepared and compacted before we go ahead and pour the concrete. And then ultimately, definition of toxic, right? Something being harmful, poisonous, continuing, something that may be a lethal or toxic chemical, right? So, of course, we all know that, greater hazards out there with concrete is going to be, it could be some toxic materials. Often it's going to be silica is going to be one of the greater risk. And then, like we said, also skin disorders like chemical dermatitis from employees that are continually exposed to concrete during the pouring and curing process. Okay. And then, of course, we know what do we want to do? We want to have an effective health and safety plan, adequate monitoring personnel, and also have appropriate PPE on site as well, right? Okay, so 1 second, folks. Okay. In addition to that, let's go to, of course, page 2 now of module 8. We're talking about fall protection, which we all know the hazards of fall protection. That's where we're going to be in our A, B, C, and D's in fall protection, right? Our anchors, our body harness, our connectors, and then our decelerators if necessary as well. And we're going to follow the following practices. What are we going to do? We're going to wear good, safe, strong boots, right, that are in good repair. We're going to watch where we step. We're going to be sure that our footing's secure. We're not going to allow us to get ourselves in awkward positions. We're going to stay in control of our movements at all times. We're going to maintain clean and smooth walking or working surfaces. We're going to fill holes, ruts, or cracks as quickly as possible. We're going to be sure to clean up any type of slippery material. We're going to also pick up litter. We're going to install cables, extension cords, hoses, so that they don't become tripping hazards for us either. If we have to climb to reach something, we're going to use some kind of strong or sound ladder or some other elevated work surface that may adequately let us get up there safely. When climbing a ladder, we're always going to face it, and we're always going to use both hands, right? We all know it's going to be 3 points of contact when ascending or descending a ladder, right? Which we're talking about either 2 hands and 1 foot or 2 feet and 1 hand. Okay. And then as you notice, you'll see different illustrations of concrete and how long it's been standing. Look at the Roman Colosseum in your left-hand page, page 2. You'll see, there you go, is a picture of some of the Roman Colosseum, over 2,000-year-old concrete, right? And then on the right-hand side, you'll see various structures and buildings as well, different public sector buildings, schools, administrative offices as well, right? Commercial offices. And then if you go to page 4, let's talk about falling and flying objects as well. So different items that we're going to do, right, in order to safeguard against falling and flying objects. We're going to do things like we normally know. We're going to go ahead and always wear a hard hat. We're going to use toe boards, screens, guardrails on scaffolds to make sure that we have nothing falling from the scaffolds, right? Basically, practice like drops programs or some other type of program like that where we're protecting employees down below from potentially falling hazards. We're also going to use tool holders or tool lanyards or ropes. For anybody who's not familiar, let me see if I can pull up a tool lanyard for you. It's what I'm talking about, like whips and tools like this. Are any of you seen these yet on your work sites? Like holding cordless drills. A lot of times you'll see like some cordless drills have a hole in the backside, right? Okay, good. Yeah. So different types of tool lanyards. A lot of times they're calling it drops programs now. Let me see if I can pull it up. It stands for dropped objects, is what the drops program stands for. Let me see. A lot of government agencies are doing it now. Um, Sorry about that. Okay, so it's called the drops program. Also, what else are we going to be doing? We're going to stack materials properly, right, to prevent sliding, falling, or collapsing. A lot of times we'll do material blocking, like I think we talked about that last week. Let me go to it again just in case. Is what I'm talking about. Is we end up doing some type of blocking where, let's see, let's do brick blocking. A lot of times when you see bricks like this on a pallet, folks, right, we'll see them intertwined like this, one direction going on one row, the next direction going to the next row. What it is, it's called blocking. And basically what we're doing is we're trying to prevent it from falling off of the pallet, right? Also, we can do bagged concrete. There we go as well, folks. Okay, there's an example. There's an example of blocking as well. And what that does is it basically interlocks the load in order to help better prevent it from falling off. Okay, and then of course either shrink wrapping it or securing it if necessary as well, right? Okay. Also using debris nets, catch platforms, canopies if possible, using safety glasses, all of our PPE, right? Glasses, shields, around any types of machines, anything where there could be projectile hazards, inspecting tools to make sure that all the protective guards are in good place, making sure that we're trained to properly operate any powder actuated tools. We talked about that last week. So what are we talking about now? I'm talking about powder actuated tools certification, and basically it's an employer, anybody who's got like ram sets or anything like that. That's what I'm talking about. Is that Hilti, um, pass load, a lot of the ram set, they'll have a little card or a template that comes with it, and for every employee you have, we're basically, as the employer, we're certifying that that person's been adequately trained on that piece of equipment. Okay. So anybody who's got any type of powder actuated tools, we talked about this on Tuesday. You'll see that ultimately, what are we talking about, right? What's the best comparison? We can compare it to a gun, right? We have a shell. Okay, let's see. We have shell or bullets, right? Whatever you want to call it. There you go with blanks. You have a gun setup, all right, a rifle setup, and ultimately we have a projectile. We have a nail or something else coming out of it. Okay, so that's why we have to use extra caution when using powder actuated tools because of the strength. They may go through brick and block. They may go through wood, depending on what the backer system is. Here's a perfect example: a fatal fact with OSHA. There you go. Employees nailing into a two by four wall, went through the stud and shot the employee. Okay, OSHA's got a number, and NIOS has got a number of these case studies on powder actuated tools. All right. Also, avoid working underneath any type of loads, right? Barricading hazards or posting warning signs if necessary. Also, ensuring that cranes and hoists are inspected to see all the components that are in good condition, to make sure that they're all compliant, lifting hooks, equipment, whatever the case may be, and then not exceeding the lifting capacity of cranes or hoists. So, like we talked about, not exceeding the capacity, but not only exceeding the capacity, but like I said earlier, anytime we get to the hooks, right, the slings, the crane itself, whatever the case is, anytime we get over that 75%, like I said, critical lift. Okay, anytime we do any of those, or if we anytime we use two lifting devices on the same piece of material. So basically, two cranes to pick up a lift, two forklifts to pick up a lift. It'll wind up being a tandem lift, is what it's called, TANDUM, tandem lift, and basically it's done with two or more cranes. So let me show you what I'm talking about. This is what I'm talking about right here, folks. Anytime we're using multiple cranes like this, we're looking at a tandem lift. Okay, that's going to automatically be a critical lift. Okay. All right, good. So let's keep on going with tool safety now. Yeah, following rules, right, that we're going to follow when it comes to safe tool use. We're not going to attempt to operate any power tool without being trained on it first on that particular tool, especially the higher risk tool or the more complicated the tool is, the more training that we're going to have to assure that we have for our employees, right? Never leaving a power tool energized and unattended. These are a lot of recaps of this material that we saw last week, right, folks, and the week before. Assuming that a safe and comfortable position before we do any work. Don't distract other people that don't work. Don't let people distract us while we're doing the work. Also, being sure that any electrical power tools are properly grounded. If they're not grounded, if they don't come with a ground, we need to make sure that they're at least double insulated. Also, we want to make sure that the power is not connected before we perform any maintenance or changing accessories. Perfect example of that is like a bench grinder, right, or a sawzall. Make sure that we de-energize it, unplug it before we start pulling the blade or the grinding wheel off is a perfect example. In addition, we also want to never use any dull or broken tools or accessories. Use a powerful tool only if it's for its intended a power tool for its intended purpose. So we want to make sure that we use a tool only for what the manufacturer intends that we use it for. Do not use a power guard that's missing any kind of safety devices or any guards. Use a proper size extension cord. So depending on easiest way to find out is read the tool. Okay. Read that piece of equipment. Let's say if you have an air compressor, you have a circular saw, read it and see what size extension cord we're allowed to use. It may be a 16, it may be a 14, it may be a 12 gauge. And as most of us know, the lower the gauge, the thicker the wire, okay? Also, use, let's see, proper extension cord. Become familiar with the correction operation and adjustments of any type of power tool. Keep a firm grasp on the power float or the trawl machine handle when we're operating it. We're talking about like for concrete finishing, basically. Be sure, let's see, power float. Let me pull it up for you for anybody who's not familiar with it. Okay, that's what I'm talking about. Power trawl or power float for anybody who's not familiar. That's what I'm talking about, and it's basically to go ahead and smooth out and tighten up concrete on surfaces. Okay, close up a lot of those pores is what it's for. Okay. Also, making sure that we have adequate ventilation anytime we're using any any gas powered tools. Make sure we minimize the risk of any type of carbon monoxide poisoning or LELs. Keep our hands and feet away from any type of cutting ends, saws, grinders, trowel machines, whatever it may be. Storing tools properly when they're not in use and in appropriate containers if necessary as well. And then also let's talk a little bit about safety precautions, right? In addition to the regular PPE that we're going to wear, remove jewelry, wedding rings, bracelets, necklaces, earrings, anything that we need to remove so that it doesn't become a wrap hazard or an injury hazard or something we can get caught up or hung up on. Also tie back any long hair, ponytails if necessary as well. Wear close fitting clothing, making sure that we don't have a lot of loose ends or loose edges. Make sure that it's buttoned up, things so it doesn't become a wrap hazard and get pulled in, right? Wearing face and eye protection wherever it's required. If we're required to wear glasses, that's one thing. If we're required to wear a shield, the biggest thing is remember that if we're required to wear a shield, we also should be required to wear glasses. So we should be wearing both, not a shield in lieu of glasses. Okay. Protecting any exposed skin by applying protective barrier creams if necessary, or wearing the appropriate rated gloves, wearing sturdy ANSI approved footwear, basically steel toe or composite toe if it's a composite toe if it's accepted in your workplace, and then wear fall protection equipment as it's required as well, right? So at a minimum, we got to follow all those standards. And then if you look on the next pages, we're just going to go through some examples here, and and it's going to show different, reinforced, pre-stressed, precast, like I was talking about earlier. A lot of times bridges, the majority of it in Houston is probably where I'm seeing the most of it, where some of it is actually still being poured in place, and many other areas nowadays it's actually coming in sections now and being assembled on the work site. Okay. And then slab on grade, like we talked about, basically a foundation. If you look at that middle picture now on page 6, we're talking about it like a slab on grade. Okay. And then some common causes, right, of form failure. This is what a perfect example of concrete pouring forms and where it may fail. Perfect example is look at the second picture again, and you'll see that they've basically pouring that form into place. And this is what's happening, right? Form ties, they may be incorrectly placed or improperly placed. Also, we may exceed the design, right, or the pressure. So it may force that form to collapse as well. Improper form construction, especially when layout plans are not provided. This is something that needs to be engineered, folks. So we need to make sure that we're engineering these forms in order to assure that they're going to be able to hold the weight of the concrete that's being poured into them. Form fillers, corners, bulkheads, not adequately designed and constructed as well. There's always a significant risk. Connecting hardware that's not installed and then not being inspected by an authorized or qualified person, right, is always a significant risk as well. And then if you look at the bottom of page 6, right, there's your basic formwork, safety guidelines. And what are we talking about? The structure, it's got to be capable of supporting the load that's created by the concrete, right? So significant amount of weight that concrete's going to be held. Has anybody in here before ever poured concrete or hauled dirt, either in a wheelbarrow, either way? Is it okay? Good. A couple of you said yes. How miserable is it to have to wheelbarrow around a wheelbarrow of concrete? Yeah, it's I know a whole lot more things that I'd prefer to be doing that are just as miserable other than concrete pouring. So, yeah, it's rough, folks, for anybody who's not familiar with it. Okay, it's constant trip hazards, slip hazards. I mean, it's just really not very not a very fun job at all. Okay, and then exposed and reinforcing steel, right, where people could fall. So, what are we talking about? Basically, shank caps is what I'm talking about. So, let me rebar caps. We can no longer use mushroom caps where somebody may be harmed unless they're reinforced. So this is what I'm talking about. A lot of people think that the standard says steel shank cap. The standard actually says reinforced cap. So mushroom caps that are reinforced like this would actually be acceptable. Okay. Also, these flat ones would be acceptable as well, but they have to be reinforced. The older ones, I don't know if you remember, folks. Let me see if I can find the older ones in here. You don't even really find them anymore. They were more like just like a gel. They were just like a rubber more than anything else, and they weren't reinforced. Okay, so let's see, soft, maybe non-reinforced or something. Okay, here you go. So kind of caps like this, right? They used to be, but they were actually mushroom caps like this, but they weren't reinforced. So as long as they're reinforced, folks, that's what we need. Okay. So nowadays, I think I don't even know. Does anybody out there that's on here tonight even remember if anybody's doing non-reinforced caps these days? Yeah, I can't tell you the last time I saw a cap that wasn't reinforced. Now, okay, technology, folks, is pretty much totally caught up with this now. Okay. All right, good. So the only reason I bring it up is, like I said, some people say, "Oh, no mushroom caps." It's like not that they're no mushroom; they just have to be reinforced. Okay. All right. So workers aren't permitted to permitted behind jacks during any type of tension operation. And what I'm talking about is let me show you what I'm talking about. Okay. Okay, so this is what I'm talking about, folks. It'll be basically cables that are going through, and they're putting jacks on the backside, and they're actually tightening up the jacks. Here you go, and tightening up the cables in order to keep them taut while the concrete's being poured or curing. Okay, so or the next day once it's going through the curing process. So anybody who's not familiar, that's what I'm talking about. Okay, let's see. Okay, so just all different types of jacks. Okay, and that's what I was talking about for anybody who's not familiar with it. Okay, all right, and then so workers aren't permitted behind them. Also, in addition to that, workers aren't permitted underneath any type of concrete buckets or buggies or anything. Appropriate PPE's got to be worn at all times. We know that. Form work's got to be erected and braced in a manner that's going to ensure that's going to support the vertical and the lateral loads. Right. Bottom line, can't have a failure. Right. We can't have employees walking over rebar pouring, walking over concrete pouring, and where there's a collapse. So it's got to be able to made whether it's vertical or horizontal. It's got to be made to sustain the weight. Also, any type of shoring equipment has to be inspected and properly maintained. Make sure that we don't have any collapses on employees. Same thing for forms and shoring, the same thing. We have to reinforce steel to be adequately supported, right, to prevent it from falling or collapsing as well. And then we have to take certain measures in order to assure that we prevent uncoiled mesh wire from recoiling. All right, anything that may harm the employee, right? Hazardous chemicals, materials with concrete. So all of those considerations we have to take and put in place before we continue working on the work site, right? Okay, so let's look at the bottom. If you look at reinforcing rebar, and then we're going to go through the bullet points of reinforcing rebar, and then we're going to talk just a little bit about. I'm going to show you a couple examples and some issues that we have to watch out for when we're talking about tilt-up panels that you'll see on page 9. That's a tilt-up construction, a tilt-up panel, and I'm going to show you a couple other pictures. Let me show you a couple other pictures before we move up. We move on, okay? This is why so many buildings nowadays, folks, are going up so quickly. And this is what I'm talking about. They're basically tilting up panels and putting panels in place. Okay, here's a perfect example of it right here. It's coming in precast. all right, or it's being poured on site on the ground, and then they're lifting it into place. Okay, and we're going to talk about some considerations that we have to take with those. Okay, so I'm at the top of page 8 now. Following safety precautions, right, to help prevent injury. And folks, I'm going to run through these a whole lot quicker because you're going to see, as y'all can tell now, there's a lot of common practices, right, that we're following throughout all different types of tasks. So I'm going to cruise us through a little bit faster as we go. Wearing our PPE, right? Footwear, eyewear, hard hats, glasses, gloves, you name it, right? Not wearing any loose or ragged clothing, right? And also, in addition to that, making sure that our footing's always solid. Wear proof of fall protection, right? We're ANSI rated fall protection. Keeping the work area clean, right? Block piles of enforcing steel to prevent sideways movement. So any type of steel that we have that may be, look at page 7. And perfect example is all those pieces of rebar there. Let's say they're taller or higher. We don't want to roll it on an employee, right? So if they were bigger or taller, we may be blocking them, okay, to make sure that they prevent from falling back on us. Also, and this and that, wearing goggles with the proper lenses when we're cutting with a torch, right? Basically, a welding or cutting operation. We want to make sure we have the appropriate rated lens in there for the operator, for whoever's doing the work, to protect their eyes. Know and observe the proper hand signals for hoisting equipment, like we're talking about, craning and hoisting, forklift, lift bars or bundles properly, right, to avoid strain. Also, we're going to make sure that we know the location of all of our co-workers, make sure that we're not putting employees in harm's way. Bend down, projecting nails. A lot of times you'll see when, like especially with forming equipment or materials are being pulled off, either pull them, the nails or the screws out, or at least bend them down or break them off, or whatever needs to be done to keep everybody safe, right? When carrying any types of bars with a partner, we need to make sure that the load's balanced as much as possible. We need to stay alert. With concrete buggies, I'm going to show you a couple of them. I think there's some in the next page, and I'll also show you on the internet if necessary. Neverland hoisted bundles or drop carried bars from checking out the form. Also, don't hoist bundles by wires by wrapping the tiebacks together, right? We want to make sure that we use an appropriate sling or appropriate binding apparatus in order to make sure that if we're going to pick up multiple loads of multiple loose pieces, first of all, we're going to want them all the same length. Second of all, we're going to want them taut and tightened together and lift them as one unit, as opposed to separate components, okay, if they're not going to be safe and secure. Also, we're going to reinforce steel with vertical structures like piers, columns, making sure that they're guyed down or tied down right. We're going to report any unsafe conditions. Like we talked about, we're going to use plastic caps on exposed ends, especially the vertical ones. Anytime where there's an impalement hazard is when we have to use a reinforced cap, okay? Anytime there's an impalement hazard. Also, we're going to use pliers to bend down loose ends, of any wires, right, that we tie. And what I'm talking about now, I'm talking about the wires that tie like rebar together and that we'll be using to bind rebar together. And then in addition to that, there may be some important safety precautions associated with tilt-up construction work, right? Tilt-up construction work, folks, like I said, is what you see on page 9 on your right-hand side, and I'm now on page 8 on your right-hand side. So what are we looking at? Is workers have to stay clear of the panel while it's being moved, right? Don't stay on the side of it. Definitely don't stand underneath it. Temporary lifting inserts used to pick up the panels have to be placed in accordance with the manufacturer's instructions. Now, it may be the manufacturer or it may be the qualified engineer themselves, but look at the next line, and this is something I want you to absolutely know. Only qualified engineers can make the changes to the lifting, to the anchor points on a tilt panel, okay? The reason only a qualified person can do that, assign that, is because, and normally it's something like an engineer, folks, and the reason being is because all of those points have been engineered into that component. So therefore, it's a manufactured piece, and that's why a qualified person has to do it. Because if we go in there and we start drilling, right, or if we go ahead and start setting pads and putting them in, or eyes or pads and putting them in the wrong place, and then we may affect the structural integrity of that panel. Okay, so that's why. And then once placed, the panels have to be braced in accordance with the manufacturer's instructions. If you look at that photo on your right hand side, that's what that is two braces. If you look at it, if you look at those two long, they look like pistons or shafts kind of. Those are braces. So when they go up, they're going to be bracing them in place, just like in the picture. If you look here on the computer, there you go as well. There's another illustration of it, of these braces. Okay. So of course, I mean, these employees, I mean, look how close they're getting. I mean, they're definitely, I mean, they're going to be there. There's a risk of these employees being harmed. But look how many different anchor points that tilt up construction wall has. Okay. And then because no concrete pouring or finishing is involved, right? The precautions associated with the handling and finishing concrete have to be observed. Okay. So there's your significant risk for tilt-up construction, folks. And like I said, the biggest takeaway, I mean, all of it's important, but the biggest takeaway that I want you to take with you is that only a qualified person can change any anchor point on that tilt-up construction. Okay. All right. So let's go ahead and keep moving. I am moving now into tools and equipment used in concrete construction. And again, safety rules that we want to keep in mind, right? I'm about to show you on screeds. I think in the next couple pages, they're going to have what screeds look like, okay? And then things that we want to keep in mind, right? Keeping those tools sharp and clean and in safe working order. Would y'all agree that pole jacks? Yeah, I'm sorry, I'm just seeing that, Jason. Yeah, pole jacks. You're talking about as far as the braces, the cross braces. Yep. Yeah. Exactly. So, folks, anybody who's not familiar, I'm pointing at the picture right now, right here where you see my magnifying glass. This is what Jason's talking about. Okay. So that's what he's talking about right there. Okay. And then they'll be adjustable. Some of them are adjustable. You see them there. They'll be hydraulic or adjustable as well. So depending on them. Okay. And so there you go. And then, yeah, so let's go ahead and go to, like I said, I'm sorry, the bottom of page 9. Again, right, a little bit of Groundhog Day here, but we're going to cover it. Keeping all tools clean, sharp, and in safe working condition. Using retaining guards, safety devices, right, whenever they're required or they come on any type of equipment. We're going to report all defective tools, machines. We're going to lock out, tag out if necessary. We're going to disconnect and lock out power machines before we service them, like we're talking about. Also, we're never going to use compressed air, like we said, to clean ourselves, right? And if we're cleaning off any surface, and then it's going to be pressed down to 30 psi or less. We're going to make sure that others, at a safe distance whenever we're doing any work, to stay out of our work area. We're going to use traffic control devices when required as well. Could be cones. Perfect examples. Look at the photo that I've got up, right? Look at all the different cones and traffic control devices that are in place, right? And then follow the manufacturer's specs and the rules and limitations of any type of equipment. And then if you look at your picture on page 10, folks, there is your concrete bucket up top, and then there's your buggy at the bottom. There's a concrete buggy at the bottom. I'll show you another one in just a moment, I think on the next couple of pages. If not, I'll show you a couple of them on the internet. And then let me go ahead and actually go to it. Okay, let's see. You have different brands, obviously. Here you go, folks. There's, like I said, all different kind of brands, right? And there you go. Takes a whole lot of pressure off of employees, folks. I mean, technology's really come a long way to help us out on all this, okay? And then, of course, we also know that we have all these. And then in addition to that, we know we have concrete pumping as well, right? Like you saw on the vertical wall that they were building a few slides back. And here you go. This is what I'm talking about. For anybody who's not familiar, here's a pump truck. Here's a pump truck. It's going from these two. Let me see if I can get us a clearer picture. Here you go. So there's concrete trucks, right? And then next to each concrete truck is a pump truck, as you notice. And what they're doing is they're pouring into like a trailer or a bed, or straight into the pump truck, and then it's pumping through the hoses and pouring concrete. So we've eliminated all the use of wheelbarrows, concrete buggies, or any other type of equipment like that. Okay. All right, good. And then let's talk about chemical dermatitis and silicosis, right? Obviously, we want to control any type of dust in the air, silica, preferably engineer the hazard out. If we can't, and then we go to PPE. Where does it come from? Often Portland cement, mortar, sand, so brick and block, so different cut and brick and block, so different hazards that we have with silica, and things that we need to do, right, in order to minimize the risk of chemical dermatitis or cement dermatitis, or silicosis, is wear coveralls or wear protective clothing, long sleeve shirts, boots, rubber gloves, goggles, face masks, using improved respirators. Like we said, if we're using and improved respirators, we had to have gone through our medical evaluation. We've had to have gone through our pulmonary test and ultimately been fit tested within the last year. Okay. Also using wet methods for cutting, chipping, and concrete. What are we talking about? Basically wet saws. So let me go to it. And it's considered an engineering control, and it could possibly be an administrative control too. So let's see, wet method cutting. This is what we're talking about, folks. Let me go to brick and block, right? It could be they're using a regular table saw there. That's kind of crazy. It's going to be something that's rated to get wet. Here you go. You see this is a gas saw here. It's a gas saw. There's a hose attachment. So where they're cutting this brick, it's engineered to where it's cutting that brick while it's wet, and therefore it's reducing the risk of dust. Okay, and there's another example of one as well right there. Okay, that's wet cutting. You see that hose, and it's a gas powered saw. Okay, and then in addition to that, wash frequently, right, with linoleum-based soaps or using lotion. That way, keep your skin from getting ashy or dried out, and control some of that dust as well. Bathing after each shift, of course, and then PPE. Traditional PPE that we use: hard hats, safety glasses, face shields, respiratory protection, gloves, knee pads, toe boards, safety boots, all of it, right? If you look on your right hand side, you'll see two different types of screeds there. You got a steel truss screed, and then you got a roller screed as well. That's what I was talking about earlier as far as finishing and evening out and smoothing out cement. That's two machines that are often used in big, large projects like this. And then we got to remember the responsibilities of masonry workers as well, right? We have to make sure that we learn all the safety rules in the site, anything from safety PPE equipment again, knowing the safety rules, knowing the general worksite procedures, being aware of any potential hazards in the workplace, and then the proper use of tools and equipment, right? So I obviously practices that we most commonly practice, right? And then let's see, I'm going from page 11 now. I'm rolling over to page, at the bottom of page 11, masonry tools and equipment. Same thing, right? So let's talk about some additional rules. What are we looking at? Position all cutting edges away from our body. We're going to make sure that we're going to try to protect ourselves as much as possible, not to be caught in some type of a cut hazard. Keeping our fingers away from any type of cutting edges. We're going to hold equipment and tools in ways where we're going to have less of a risk to be hurt. Folks, I'm going to send you a video. You see that power saw down at the bottom? I'm going to send you a video of a runaway blade. The only way I can imagine that way, and when you see it, it was from the newscast. When you see it, I think it'll surprise you. I think a few of you have already seen it. Anybody took the 510 or the 511? I think when we did power tools and machines, I probably showed it to you already. And the blade actually ran away, went into a house. Okay, went into the side of a house when they were cutting concrete on the street. So it looks just like that power saw right there, maybe a little bit bigger. Okay. So items that we want to do also when working around electrical hazards or equipment, right? We want to use insulated tools or wooden handles. Never use broken tools or tools with loose handles or dull blades. Maintain all tools in good working order. Make sure they stay clean as possible, dry and sharp as possible as well. Also, we're going to store tools properly when they're not being used. Nobody says that they have to be in an approved container, right? They just have to be stored properly, right? Any defective tools, machines, or any other type of equipment has to be tagged and reported, as we talked about. And then, of course, an illustration on page 13 of all the required PPE that we're required to use, right? We're looking at examples of goggles, hard hat, our respiratory protection if it's required as well. With concrete, we want to wear long sleeve shirts. And the reason we want to wear long sleeve shirts is because it'll give our skin extra protection from that chemical dermatitis, right? So the preference is long sleeve shirts. Remember that. Well, that might be a good quiz or test question as well, folks. um, Wearing clothes that are not loose fitting, right? That fit adequately. Wearing gloves when we're working with concrete. Wearing knee pads as well, or boots. Wear pants with no cuff to catch the mortar. So cuffs, we really want cuffless pants in the workplace. Uh, we really don't want them, period, because we always have the risk of when we're doing hot work, chemical work, and or now with getting concrete caught in them as well. I'm going to go so far to say, and this is where it gets tough. Depending on what type of concrete work we do, we're normally not supposed to put our pants in any type of boot. But with concrete work, sometimes you probably wind up doing it. I tell people another way to do it really is roll them up, and tape them around the boot, right? So just keep that in mind as well, okay? And then let's go to page 14. I want to show you a few items there, folks. And there you'll see we have a masonry saw, right? A wet saw. As you see, that one is actually gas powered, as you see there. You'll also see that you have the rotary core masonry bits, masonry brushes, basically to go ahead and clean brick and block and wet concrete. We've got a trowel and a stone mason sledge. One thing I absolutely want to point out about the stone mason sledge is just keep in mind with the stonemason sledge that a traditional sledgehammer, right, as we know it, normally has that big side on both sides, right? So let's go to sledgehammer. Okay, so normally we talk about a sledgehammer, we're talking about this, right, on both ends. Okay, but a stonemason sledge, it's going to be different. Stonemason sledge is going to be like what we see right there in the picture. And the reason being is because they're using one side of it to break the brick. Okay, they're using one side of it if necessary to where they're gonna break the brick in half or break it in a portion, in areas that they can't have a solid brick on an installation. Okay, so just I want you to remember that stonemason sledge because we may talk about that in the near future. Okay, all right, folks. So let's that's that. Let me do this. Is that we got one section left, folks? Section 9. We only have a few minutes left, so I think what I want to do is I just want to point out a few items to you in section and module 9, and I'd rather not get into it. That way we can get a full push through module 9 next week, and then maybe just do a review of the third book to get everybody started. Okay, for on Tuesday, and then next Thursday we'll start the new book. So let me just take you through section 9, kind of let you know what you're looking at. And if you want to read on your own, that's great. And if not, we'll, we're going to pick up next Tuesday anyway. Okay. So I'd rather not push it. Are you guys okay with that for tonight? Okay, good. Okay. All right. So section 9, right? This module 9, excuse me, is going to be the last section. We're going to be talking about a lot of material handling, right? It's going to be proper lifting procedures, ergonomics, basically. If you go to the next page, page 2, if you want to read ahead, that's great. Okay, working at heights. I mean, you'll see that a lot of it is going to be it's going to be a little repetitious. Okay, go page 5. You'll see where they're blocking brick. We talked about that tonight already. Blocking brick, also storing cylindrical storage, like we talked about, putting blocks as well so they don't run off or harm employees, okay, bags of cement or dirt or whatever it is, you'll see that they're properly stacked as well and blocked. Okay, we'll go into the next module. You'll see it. We'll go into like hand trucks and carts. Obviously, if you look at page 8, somebody hijacked a Home Depot flat cart on the bottom left-hand page, right? We have hand trucks, wheelbarrows we're talking about. We'll talk a little bit about like roller skids and pipe mules. You'll see so if you ever hear pipe mule, folks, that's what you're looking at, right, on the right-hand side. And so employees don't have to be carrying all that weight, okay? We'll go in. If you keep on flipping the pages, you'll see jacks and pipe transport. We'll see a regular manual jack as opposed to a motorized jack. There's the other concrete barrel that I told you about, or for dirt, right? The powered wheelbarrow. And have y'all ever seen any of these run, y'all? These little powered wheelbarrows, they're hydraulic, and they're gas operated. They're strong, huh, Jason? Yeah. Let's see, Carlos. Yeah, you too, huh? Yeah, they're very strong, folks. They don't move very fast, but they move way faster than a human does. I mean, they move fast enough, though. Okay, and then if you keep on going, you'll see a couple more concrete mule on the next page in the upper right, page 12. Okay, you'll see another illustration of that same link belt crane on page 14. Right, we're talking about different hitches and checkpoints. If you look at rigging, we've talked about rigging a few times, but we're going to talk a little bit more about it next week. All right. And I think it ends around page 19 to 20 or something like that. Yeah, page 19. Okay. So what we'll do is we'll pick up next week on module 9 on Tuesday. I'm going to send y'all some extra resources tomorrow. I'm going to load, we had a bunch of people that didn't get on tonight. So I'll be loading this module on there. And then, like I said, we're loading previous modules. We've just been having some internet issues this week with those tornadoes. So we'll be loading previous modules, and then we're kind of pushing ahead and going to start loading up more of the what you call it as well, of the modules for the third book and the previous modules as well. Okay, so folks, let's do this. Let's go ahead and give me 1 second. Let me go ahead and shut this down really quickly. Okay, great, folks. Well, that concludes the night. We're going to go ahead and wrap it up for this evening. If anybody's got any questions, just feel free, like we said, as normal, just feel free to call me, text me, email me, okay? And I'll be glad to answer any questions I can. Anybody who needs my phone number, again, 504-231-1000. Okay, if not, you have my email. And then I will plan on seeing everybody next Tuesday night, okay? So thank you so much and have a great night.